this for a little while. So today we're going to have a little look at trigonometry. It's going to be a little bit of a long one, so feel free to break it up into little sections. We're going to talk more about how to use the ratios rather than where the ratios come from, but I have made a little playlist if you're interested about how the formulas are derived, which talks in a lot more detail. So feel free to have a look at that on your own time, but this video, like I said, is going to look at, here's a question, how can you solve it? So this is for finding angles and sides. You can see from the little picture there, we've got the angles, and that's what we've probably been stuck on because obviously we've been using Pythagoras and that doesn't work for everything, but we can also use it to find sides as well. So let's jump straight in. Like I said, this is on my YouTube channel, so go to that video. I did steal the videos from somebody else, but they're quite good at finding out mathematically where those formulas come from. I'll put that little link there in the description below. So you've probably seen these three buttons on your calculator before, and I haven't got the full name there: sine, cosine, and tangent. These are the three basic trigonometric ratios, and these are the ones which we're going to use in grade 8. And all of these refer to the relationships or the ratios between the sides and the angles in a right angle triangle we're going to look at first of all. Though they do look at other shapes, we're going to focus today on right angle triangles. A little, and this is not for everything, but just as a general rule of thumb that's going to help you get started, okay? Think of it as the little ones at the top are for angles and the big buttons are for lengths. To access the little bits at the top, you need to use your second function on your calculator. I'll show you where that is in a second. But second sine gives you the sine to the power of -1, cosine to the power of -1, tan to the power of -1. That's what it looks like. So we're going to use the top ones for angles and the bottom ones for lengths. Now, first thing we're going to talk about before we do any solving is the most important thing when you're using these trigonometric ratios, and that is going to be labeling. If you get the labeling correct, then the rest of the question will actually not be too bad. Similarly, if you get the labeling wrong, then everything is going to go bad. So really focus on the labeling. As you can see, we've got a right angle triangle there. I've labeled the little right angle with right angle, and we've got 4 parts that make up a trigonometry question. The first is the little angle, and we've got like a little symbol, looks like a 0 with a line through the middle. We call that theta. That refers to an angle. It can either be an angle that we know about, or it can be an angle that we're trying to find in the question, depending on whether it's a missing side or missing angle question. We've got the hypotenuse, which we talked about in Pythagoras, which is like the longest side. We've also got what we call the opposite and the adjacent. All of these are in relation to the angle. Okay, the angle is kind of like the central part of this question. So when we say the opposite, we're saying, well, look at that angle. Opposite that angle, i.e. on the other side, is the opposite side. If I was to highlight this line, we can see that that line is not touching this angle. They're kind of two separate things. The opposite side is always the one, it's not always the one on the left, and I'll show you some examples in a minute. It's the one that's not touching the angle. So we can see we've got the angle on this side, we've got the opposite here, and they're not touching. The adjacent, the word adjacent means next to, and you can see this one is the one that's next to the angle. And the other one that's next to the angle is this one, but this one isn't adjacent because it's the longest side, so it's the hypotenuse. So just a little summary there, and you can always pause that and have a little read. It's cropping off a bit at the bottom, but that's okay. I'm just going to pull this up a second. Just going to shrink this down a little so we can see the bit that's cropped off the bottom. There we go. So that's kind of the information you need. Notice we've got the right angle. We're saying, you know what, we know it's there, but we're not using it at the moment. We can use it, but we're choosing to use that one in the bottom right. You might have more than one angle in a question, but you only choose one to deal with. So we've chosen that one in the bottom right, and that's our angle. You can't mix and match. You choose whichever angle you're using in the question and stick with it. So what does that look like in practice? Well, let's say we had these 3 triangles here. Let's start with the basics. We're going to label the triangles. First thing we always look for, and you can see that we've got triangles in different orientations, but we've got an angle in each one. So we're going to start off by thinking about those angles. Let's do all our opposites first. So in this first one, we've got an angle here. Opposite that angle, i.e. the one that's not touching, is this one here. Sometimes you'll see it labelled op for opposite. Okay. Sometimes you'll see it labelled with the full word, so that's opposite. Or you might just see a big O, O for opposite. Now this second one, we can see we've got the angle here. So this one on the left-hand side is not the opposite because it's touching the angle. So it's not that one, but if we go to the opposite side, we can see we've got the opposite here. Similarly, we've got a triangle looking at the angle here. Can't be that one because that can't be this one. It has to be the one that's opposite. So now we've labelled the opposite angles in the triangle. We'll do the hypotenuse next. Hypotenuse is just the longest side. In the first triangle, we can see H for hypotenuse. It's the longest side here. This one here is still the longest side. In our third triangle, these two are quite short. That one at the bottom is longer. So this is the hypotenuse. Let's just check we've got this right. We're looking for the A for adjacent next. We can see we've got an angle here, and next to the angle is the adjacent. Remember, adjacent means like next to. Similarly, we've got the angle here, and next to that is the adjacent, and angle next to it is the adjacent. So when we're done with that and you tidy up a bit, it should look like opposite, adjacent, hypotenuse. We've got next to, opposite, and longest. We've got opposite, we've got next to, and we've got longest. So now we know which side is which in each of our triangles. Until we've got that point done, we can't do anything else. Okay, let's keep going. So, that's the extra slide. Something like that, yeah. We've got our three triangles, they're labelled. How are we going to use that labeling? Well, now we need to use our ratios. And the good news is I'm just going to kind of give them to you today. Nope, what am I doing? Not going very well. And I've already got them written out. These are our three ratios. We know we've got sine, cosine, and tan. So the most important thing when we do each question is choosing the right one. You've got three options, and you're only ever going to choose one of them. So we need to make sure every time we're using the right ratio. Now, when we think about those, okay, let's just think about these for a second. We've got sine, cosine, and tan, and each of them contains two sides. The first one is the opposite and the hypotenuse, or O and H. So we can rewrite that as O and H. This can be rewritten as A and H, O and A. All three of them are fractions, so that's really important to remember. Fraction is obviously a ratio of relationship between the two. All of them have the angle as the subject, or the sign of the angle, so we've got angle, angle, angle. But don't worry, like Pythagoras, we can rearrange it. All of them only have two, none of them have all three. So, how does that look in a question? Well, no, we'll do some more later. I'll come back to that in a second. So, as we can see here, in a question, you don't get given all the information. Here, you're given some information where you're given a side and an angle. Here, you're given three sides. Sometimes you'll get given sides and angles. Depends on the question. So, let's say we wanted to solve this question here. We're not going to solve it yet. We're just going to look at how we'd solve it. First thing we do is we'd label it. Well, we did our labeling a second ago, like this. So we can say we've got the opposite, the adjacent, and the hypotenuse. The angle, of course, will be theta. We can do the same thing again here. We've got the angle is here, so this is opposite, adjacent, and hypotenuse, and this is theta. Here we've got opposite the angle, next to the angle, and the hypotenuse. Using a highlighter can be helpful here. Let's say I was going to solve that first question. Well, we can see that we've got an angle, we've got a hypotenuse, and we want to find the adjacent. We can see, however, that we have nothing about the opposite. We don't want to find it, and we don't know anything about it, so we ignore it. So we can see for this one, we've got an adjacent, a hypotenuse, and an angle. The next question, again, let's highlight. We can see we know the hypotenuse, we know or want to find the opposite. We've got an angle, but we have nothing about the adjacent. So we can say we've got the O, the H, and the theta. We want to find one, we're given two of them. Finally, in the last one, you can see we've got angle, adjacent, opposite we want to find, but nothing about the hypotenuse. So we've got these three, not hypotenuse, sorry, the theta, these three things in our question. So any question you get will only have 3 bits of information. You'll get 2 of them you're given, and 1 of them you have to find, and something will just be ignored entirely. Sometimes we'll have a question like this. Hopefully you'll all recognize some of these triangles from our Pythagoras. And again, we can label them. Even though we know them, we can still label them with their sides. There's our angle, so we say opposite, hypotenuse, and adjacent. We say opposite, hypotenuse, and adjacent. Look opposite over there, adjacent, and hypotenuse. We're given all 3 bits of information for this question, so we get to choose which pair we want to do. We might say, I want to do an opposite and a hypotenuse. Well, that means I'm choosing those 2, which is sine, which we said was opposite and hypotenuse. In the second one, we can say, I might say, actually I want to use the opposite, but I want to use the adjacent this time. Well, that means I'm using the O and the A. Well, I might choose to use tan in this question. And finally, in the last one, I might say, let's do something different. Let's use the A and the H. I don't want the O anymore, so I'm using the cosine. So choosing 2 bits of information that you know to find one that you don't. And then we'd say ignore that, and ignore that. And we choose one to ignore. So you can either think of it as choosing 3 that you want, or another way to think about it is, let's choose one to get rid of that I don't want to deal with, something I know nothing about or I don't feel like I need to know in the question, and you can cross it out. Okay, so 2 types of questions. Let's have a look at how we can start to use these ratios. You get questions looking for missing sides and questions looking for missing angles. It's pretty easy to distinguish between them because you just look at what's missing. In those ones on the right, you can see that the angle we don't know, but it asks us about in the question, and we've got this kind of blank bit here. We've got a blank side. So we say ignore those blank sides. Looking at the other question, we can see we've got an x to find out in each question, and we've got a blank side again, which we're going to ignore. So let's look first of all at some angle questions. Questions where it's got theta and 2 sides given. How do we do these? Well, we need to, and notice I've not really talked too much about the ratios because they're just something you're going to have to memorize. Before we even think about any ratios, we always start the question with labeling. So here's our angle. That's what we're going to find out. We can see this one here is the longest side. We've got one on the other side, that's our opposite, and the adjacent is something we're going to ignore. Next, so we're ignoring the adjacent, we're going to choose our ratio. Remember, we've got 3 options to choose from. So we look at the information we have. We have an opposite, and we have a hypotenuse. Well, when we look at this, the easy way to do this, let's highlight it. Let's imagine first of all start with the hypotenuse. That's going to be involved in my question, so at the moment I've got 2 options. There's a hypotenuse here, so I might be able to use sine, or I might be able to use cosine. But we can see that this does not contain the hypotenuse, so we're not going to use tangent. Then we say, okay, we've got the opposite over here. That one is included here. That one's got both of them. Let's use this one here. Now we know we're going to use sine. So we're going to use sine because we're ignoring that. So now we know we have this formula. We're saying the sine of the angle, this ratio, this mathematical function on our calculator, which if you watch the video you can see what it means, the one I showed you in the playlist earlier. We're ignoring the adjacent, let's just rub it off because I don't even care. We can see that the formula says the sine of the angle is equal to the opposite divided by the hypotenuse. And now we do some substitution. Well, we don't know what the angle is, so we're going to have to leave that as an unknown, that theta, that unknown angle. But we do know what the opposite is. The opposite O is 8 meters. That's the one we highlighted in green. Oh, terrible highlighting, let's click highlight. We can also see that the hypotenuse, the longest side, is 10 meters. That was the one we highlighted in yellow. 8 divided by 10 is a nice easy fraction which we can put as a decimal or a fraction, your choice. And if we do it as a decimal, we get 0.8. Now, this is the important bit. 0.8 is not the size of the angle. 0.8 is the fraction, the relationship between those two sides. But what trigonometry does is it takes the ratio between those two sides and we can use it to convert, if you will, that into the angle in degrees. How do we do that? Well, now we're going to have to use our calculator. If you don't have your calculator, you're going to have to use like an online one. Okay, just learn the names of the functions and what they look like. But it is very important that you have a calculator. You can't do this without one in grade 8. So we take this number here. Remember, we're trying to find an angle. So we go back to our calculator and we talk about the buttons. We said that the ones underneath, so this one here, is for the sides, but we want to find an angle. So you type second and sine. That will bring up this one here. It will say sine -1, like that. Now we want to take this value and we want to find the angle from this value. So we type sine -1, 0.8. When we type this in to our calculator, here's one I made earlier, okay, we type that into the calculator and it gives us 53.13 degrees, 2 decimal places. It's going to give you a big long decimal, you just want 2 decimal places for today. So, let's recap what we did there. We said label, choose the ratio, substitute the numbers, and then we used our calculator to find the answer. So let's do the next one a little bit quicker and we'll kind of run through it a bit faster so we can see what it looks like when you're doing it for yourself. So you're going to need these things for every question. So that's why I've made a little template there. The ratios and knowing you're going to use those buttons on the calculator. So you're going to see that little template for the rest of this. I would say for when you do questions later on, if you write the ratios at the top of each page, it stops you having to flip back and forth. You can just have them to read from. Or you can have them on the screen as you work through these. So, let's imagine you're doing the next question. You've got 6, 2, theta, right angle triangle. Step 1, let's label. Well, we've got an opposite over here, and we've got an adjacent here. We have a hypotenuse, but we're going to ignore it. Opposite and adjacent, we look at the bottom, we say, well, that's opposite and hypotenuse. That's adjacent hypotenuse. This one has an O and an A, so we're going to use that one. So we take our ratio, We put the numbers in. The opposite is, of course, 6. The adjacent is 2. This tells us that the tan of the angle is 3. Not 3 centimeters, just the number, just 3. Then we choose the right button of the calculator. We want an angle. So we put that in. And when we do that, it gives us 71.57 degrees to 2 decimal places. So we labeled, we chose the ratio, we put in the numbers, and then we get the calculator to pop out the answer. Should we see that one more time? Again, look at the angle. Well, we don't want the opposite this time. We want the longest side and the one next to it. We say, well, that's got opposite in, that's got opposite in, but this one has A and H, so we're going to use cosine this time. We put in our numbers. So what is the adjacent? Well, we look at it and go, oh, it's 5. That was weird. The hypotenuse is 20. We could simplify to a quarter. We don't need to. So now we know that the cosine of a quarter, we're going to put a quarter, but you could have left it as 5/20. If you want to, you can also use your calculator with fractions. So we could have said the cos 1/4. And we do this, and it gives us 75.52 degrees. And as you can see, it's an acute angle, but quite a big one. That looks about right. The reason I said about the acute is sometimes, let's say we accidentally put the numbers in wrong and it gave us 750 degrees. Well, we know that that's not possible. If it gave us 175, well, we know that's obtuse, that's too big. But 75 looks about right. So when you type it in, just think about, is that a reasonable answer? So let's recap the steps. Label, choose, substitute, calculator. Let's have a little look at some missing sides. And as you can see, step 1 is label. So let's jump in with some labeling. We've got an opposite next to it and longest. We're not going to use this one because we don't have anything, it's blank. So we're going to do A and H. Now we've got A and H. We choose our ratio. Well, this one's A and H, so we're going to use cosine. Next thing, substitutes, we've got cosine of the angle is equal to A over H. But this time, we actually know the angle. Instead of just putting theta, we can actually say, well, it's 50 degrees. It's there. So cosine, we know the adjacent, well, we don't know what it is. It's just x. That's this one here, isn't it? But we do know that the hypotenuse is 8 centimeters. So now we're left with a situation where we can't just type numbers into the calculator. We're going to have to do some rearranging. We've got a fraction which is x over 8. So we can think of this another way and say, well, x over 8 is equal to cos of 50. So we're just turning that around. To solve this equation, we need to multiply both sides by the denominator, which gives us x is equal to 8 times cos 50. And if we type that into the calculator exactly with the brackets, 8 cos 50, sometimes your calculator will put brackets on for you depending on your calculator. That's fine as well. And we type that into the calculator exactly as I've written it. Oh, don't go on to screensaver. There we go. And we say, well, x is equal to, and I look it up and it says 5.14 centimeters because it's a missing side. And we used cosine. We didn't use these two. Let's try another one. You'll notice that I'm doing the sides a bit faster than the angles because it's basically the same thing. You're just using the formula in a slightly different way. Think of it like Pythagoras, when you do different sides, A, B, and C, you don't do anything different except you might do subtracting under the square root instead of adding. This is the same idea. So Let's do a whole question on one page. Let's label. We've got opposite, hypotenuse, and adjacent. We're going to use opposite and hypotenuse. Opposite and hypotenuse. Choose our formula. Sine of the angle is opposite over hypotenuse. We know the angle is 80 degrees. We know the opposite is x. We know the hypotenuse is 12. So we can multiply both sides by 12, or the denominator I should say. So it's going to be 12 times sine 80 is equal to x, and we type that into the calculator, and 12 sine 80 is 11.81 centimeters. Now we know the longest side is 12, and this is 11.81, so it's very close. But when you look at that triangle, it's kind of very long and thin. It's going to be quite tall. Yeah, the angle's 80 degrees, so it's not going to go much different. So it's going to be quite close. But we know it has to be smaller than the hypotenuse. If it was 12.81, you know it has to be wrong because the hypotenuse has to be the longest. Let's try one more. This time with some decimals. Okay, first step, label. So we've got our angle here. We're looking opposite for the 5.13. We look next to for the adjacent, and the longest side is the hypotenuse. Notice even though it's x and we've got a variable, we still label it as A for adjacent, not A for a variable. Choose which ones we're going to use. Well, we've got adjacent and opposite. Oh, look at the bottom. Oh, that one's adjacent and opposite, so we're going to use tan. So tan of the angle is opposite over adjacent. The angle we have is 25 degrees. The opposite is 5.13. The adjacent is x. Oof, so now we've got a bit of an issue. Now we've got x on the bottom of that instead of before where it was on the top. So that means we're going to have to do something slightly different when we rearrange. Well, what we could do is multiply both sides by x to bring that out. So we'd have x times tan 25 is equal to 5.13. Then we could divide both sides by tan 25. I'm going to show you a quicker way to do this in a second. So it's going to be 5.13 over tan 25. And then we type that into the calculator, and it gives us x is equal to, let me have a look at my answer, 11 to 2 decimal places. Now, a little sneak tip here you can do. Let's go back to that stage when we had tan 25 is equal to 5.13 over x. What we can do here to save ourselves a little time is we can do a little switcheroo. We end up with this situation. You can switch the denominator with the number that's out, or the value that's out. So we could have just gone straight to x equals 5.13, stays as the numerator, but tan 25 becomes the denominator, and then gives you 11. Please, when you're doing this, use the fraction button, okay, which is slightly concealed there. I'll just reveal that. Okay, use that fraction button when you do this. So you'd put 5.13 fraction button tan 25. And that is pretty much it. There's harder questions, there's more complex questions, but that is the basic idea. Okay, label, choose, substitute your values, use your calculator. Okay, top one's for angles, bottom one's for sides, and remember to label it correctly. Okay, if you still aren't sure about the labeling, before you even begin, just go right back to the beginning of this video and watch that labeling section again. If you get the labeling right, the rest of it will be okay. You've got the different formulas there. You don't need to remember these, you don't need to memorize them, but it does help. Okay, but you'll get given them for your work as you go through this year. But sometimes people talk about the acronym SOHCAHTOA because you've got the different letters. TOA, SOHCAHTOA. You'll hear this if you watch any videos or hear people are talking about tuition or Kumon, whatever. SOHCAHTOA is an acronym to remember it. Okay, but at this stage, you're going to get given it every time anyway, so don't worry too much about memorizing it, but it is useful to know. And that little page there, if you're really thinking, oh, I'm not super sure about this, then maybe keep that page up, pause on that page, and that's like a good starting point to teach you about how to get going with these questions. This is for angles and for sides, okay, because it's the same steps every time. And just remember, when it's sides, you may have to, like we did here, where we had it on the bottom, you may have to do a little switcheroo. When it's on the top, you might have to multiply by a denominator. And when it's an angle, let's go right back, you're going to have to do your inverse functions. Okay, and that is enough for today. So I'll leave that up. Have a go at these. Use that to help you. And as always, I'll be around if you need me.